Am I visible? Am I visible? Okay, good. So just a second. Give me a minute. So, good evening, everyone. Today we'll be having a look at the parts of speech tagging and hidden Markov models. I hope everyone has gone through the lectures in this week. I hope everyone has gone through the lectures that were there in this week tutorial. So there were two major components, that is part of speech tagging and hidden Markov models. And today we will be having a look how to perform them using the Python programming. Okay. So shall we start? Shall we begin?
Yes, ma'am.
Okay. And I hope the lecture and the notes were accessible to you from the last 2 weeks. Were you able to access the YouTube videos and the PPT and the code notebook shared with you? All of you? Anybody having any accessibility problems? Okay, good. So let us begin. Let me begin by sharing my screen. And if you have any doubt, please raise your hand. Okay, so let us start. So today we will be having a look at the parts of speech tagging. So can just a second. Yeah. So can anybody tell what parts of speech tagging is? If you have gone through the course, then you would have an idea what is the simple definition of parts of speech tagging, or say why we need to do, what are the different parts of speech that we are referring to here. Anybody any idea? Please speak up. We shall try to be as interactive as possible. These tutorials are for open discussion only. I hope the other two TAs have covered numerical problems on these. How to compute the maximum likelihood, the conditional probability, Naive Bayes theorem. So anybody any idea what parts of speech tagging is?
Yes, ma'am. It's assigning POS to words.
Okay, so what does POS refer to here? That is a correct thing, but a little bit idea what how in general would you say a POS is? What is POS?
It's nothing but parts of speech, nothing but verbs, nouns,
Yes.
determinants, all those things.
Correct. So it could be either adjectives, prepositions, interjections, verbs, nouns, pronouns. Okay. And we saw this concept earlier also in the case of lemmatization, that when we are doing the lemmatization, sometimes we need to identify what the parts of speech is. Say the part of the speech is a noun. So should we try to lemmatize it? We shall not try to lemmatize it in that case. Okay. So, there were different what say tree banks that were being used. So one very popular tree bank that we use in parts of speech tagging is pen tree bank. So I'll keep on writing the notes here so that you guys can refer to as and when needed. So a very popular pen tree bank. What is this and what does it do? Let me tell you. A pen tree bank, what it would do, it lists all the possible tags. So there can be different categories of tags. It could be nouns, pronouns, as we said earlier also. And these tags are nothing but the categories. Okay, categories that word can possibly belong to. And this just tell me one thing, like a word will always be a noun or it will always be a pronoun? Is it hard coded, is it predefined that a particular word should always occur as a noun or a pronoun, or it can vary? And if it does vary, then what does it depend on? What is the determining factor?
It may vary, ma'am.
Yeah, it may vary depending on the context in which it is being used.
Yes, yes.
It can be noun, it can act as pronoun, it can act as a verb. So one example that we saw in the lecture was regarding the sentences like race, right? So say the president is of Asian race. Okay, race is like what community he belongs to, whether it is Asian, Southeast Asian, African, European, and Latino, Hispanic, like all of those. And another variable, another possible part of speech for the word race could be a verb, right? The people are running in a race. Here it again, race is a noun, but there can be certain instances where this word race appears as a verb also. Okay, so parts of tags are nothing possible parts of speech, that is tags, which is nothing but the different categories that a word can possibly belong to, and it can vary for, let's say, a particular word is occurring 40 times, but the 40 times this word is having a particular category, it can keep on changing. Sometimes, as I said again, it can vary. A word appears 10 times, but it cannot be the case that all the 10 times it will be assigned the same category. Okay, it can vary for every word since it depends on the local context. Okay, local context means what are the surrounding words to it, in what sense it is being used. Okay, so what is pen tree bank? If you go to Google and search, it can list you all the possible like it is a date like the different categories. And if you see here, there are 45 categories nearly that are listed. Okay, 36 in this, and there is some another one in which you can have 45 categories. Okay, so so shall we start? We will start here with the average perceptron tagger. But in NLTK, again, the library that we are going to use is NLTK. So can anybody tell what NLTK stands for? I taught in the previous two lectures also what NLTK stands for. And then we will
Natural
see.
language
Natural
toolkit.
language toolkit.
Correct. Very good. So it contains the following taggers. There are a variety of taggers that are available, but we will be using only some of them. This pen tree bank, it if you see here, it lists like what is the category this word is being assigned. You may not know, like you write a simple sentence and it gives you DT, then you do not know what DT is. So you could see its description, like it is a determiner. What is determiner? A and the all of those, right? And adjective, adjective is denoted by JJ. Adjective could be yellow, beautiful, lovely. Okay, so like these, there are different parts of speech. And we have the following taggers in NLTK. Like one is CRF tagger. Another one which we will look into today is average perceptron tagger. And I will tell you how you can, if you want, you people can also do coding hands on. I have told you it's always a better thing to do. Brill tagger, that is nothing but a rule based approach. So this tagging, parts of speech tagging, is also a rule based approach. Why? Like let's say a particular word, if you saw in the lecture slides, So there was this thing, a particular word is preceded by a determiner, then it will change into some noun, and there was a specific category of this word when it will change into noun. So this part of speech tagging is also a rule based approach. We will see what are the different rules that will come. And yet another one and very efficient parts of speech tagger is Stanford Post Tagger, released by the Stanford University. Stanford parts of speech tagger. Is it clear till this point to everyone what we are studying, why we are studying? Any doubt till now? So yeah, as I was saying here, I'm assuming that there is no doubt. So continuing. So as I said that there are different tree banks. Yet another one is UD tree bank, that is having UD. What does UD stand for is Universal Dependency Tree Bank, and I suppose it is having 45 categories. Let us check. And you could use any one for experiments today, like for the programming exercise today. Okay, it is having 200 tree banks. And since there are different languages in which the text can appear on social media, so we can use it for English language, we can use it for Hindi, we can use it for several Indic languages, French, Spanish. So what you need to do is you need to refer to that particular tree bank for that particular language you are trying to do. Okay, so today let us try with the NLTK pause tag. I have the snippet ready, but for your reference, how I did and what I did, I will copy these and run it side by side so that you also have clarity on how to run it from the scratch. But if at any point you are having any doubt, let me know. Okay. Okay. Clear to all? So today we will try two
Yes, ma'am.
libraries. Today we will be trying two libraries, NLTK and Spacy. And if time allows, we will also look into others. So first of all, I'm doing the simple thing, importing NLTK and downloading the punctuation package, right? It's my humble, okay. It's my humble request to everybody to join by 7:10 at max. I cannot be repeating the same content over and over again. Otherwise, the topics are left behind. So see, I downloaded this. Say now I don't know how to. I didn't know like I have to download this parts of speech tagger. I just simply copy this sentence and put it here, and whatever I'm missing, it will tell me. So I am just importing tokenizer, word tokenizer from NLTK tokenize and sentence tokenize. These processing steps we saw if you had attended my previous lectures. So what we are doing, we are applying the parts of the speech tag on word tokens itself. First, we have tokenized the sentence with respect to words. Like let's say a paragraph is made up of multiple sentences. First, you will tokenize it by this at the sentence level, then at the word level. Okay. So now after we have tokenized it at the word level, we will try to identify. Since I said it is the category to which each word belongs, so you need to identify the parts of speech for each and every word. Okay, clear? So let us see. And whatever dependencies I am missing, it will tell me. Okay, so now see why I had written this line in my code notebook. Why? Because it said that you are missing some, you have not specified which tagger you would want to use. Say I want to use this average perceptron tagger. What I will do, I will just copy paste this statement and put it above, so that first that package is imported and later I am using it. Okay, need not import NLTK again, we had already imported it. Just need to download the specific parts of the speech tagger. Okay, so say we downloaded it. Now let us run. So see here, what does the output denote? First, it is denoting for the first sentence, he is a preposition, verb was is a verb, being is a verb in the. What does VBG stand for? Say now I don't know it. What is VBG? I'll go here and check. What is VBG? VBG is the gerund or the present participle. What is gerund? Any word followed by like its suffix is ing, walking. The verb in the base form is walk, but when we attach ing to it, it becomes gerund. So be here, what is the verb? Is the verb, right? Is the verb here, right? Is plus ing, or you could say be plus ing. So it became what? Participle. Oh, sorry, gerund. VBG. Verb in its gerund form. Okay. He was being opposed. Opposed. What does VBN refer to here? I am also don't know. I am referring to this verb in the past participle form. It is in the past tense. He was being opposed by. By what does by? What is in here? Let us see. What is in? In is a preposition. Also we know, we just checked it. Okay, because earlier for PRP is the PRP is the pronoun. For do not confuse it by in, that PRP should stand for preposition. Okay, in is the tag for preposition. Okay, like this you can analyze. Is it clear? Is it clear, or should I explain for the remaining 3-4 tokens as well?
Clear, ma'am.
Sorry to interrupt you, ma'am.
Yes, please.
We can't see the screen properly.
But I am already sharing it. Is it not visible to anyone?
Yeah, can you zoom it, ma'am, please?
Okay. Just a second. Control. Now can you see?
Thank you.
Okay. Shall we proceed?
Yes.
Just a moment. Let me connect my charger. Otherwise, it will run out of battery. Just a minute. Okay. So shall we proceed? I hope my screen is still visible to all of you. And I myself is visible as well as audible. So let us see. Can anybody confirm the connectivity is still there? I am
Visible, ma'am.
Audible, screen is visible.
Both are good, ma'am.
Okay, let us see now. So, as I was saying, we all understood what gerund is. You need not remember. Maybe in the exam they can ask you, but for you can always refer to this. I'm sharing the link in the chat box as well for the pen tree bank. Also, you could use the UD tree bank. I told universal dependency tree bank. Can you please zoom your screen? Okay, great. Already zoomed in. I hope it is visible. So we are doing the parts of speech tag on the word tokens. Okay. And as you see, as I said, Charles. Charles is the name of a person. So it will always be a noun, like a proper noun. See, what does NNS stand for? Proper noun. Why? Because it is Charles LES, so it takes it as a plural, NNPS. Okay? Clear? Anybody having any doubt here? So see, as I was saying, let me point this out. Reason could be a verb as well. He reasoned about this particular plan or this particular fact, right? But here we are using reason as a noun. It is depending on the context, right? Context is what sense it is being used in. What are the surrounding words to it? ठीक है? क्लियर है यहाँ तक? किसी को कोई डाउट? And it is not always necessary that you should like do the sentence tokenized. You could directly put this all of your sentence in nltk dot pause underscore tag. Let us try once if we are able to make it work or not. So what I am doing is trying without the word token. See, let us, is it, does it work or not? Sentence. Okay, it says expected a list of strings, got a string. So what should it be? Let us apply it on the sentence level. Sent. Okay. I think it is necessary to do this tokenization before performing the parts of the speech tagging. ठीक है? क्लियर है सबको यहाँ तक? बताओ, कोई डाउट? Anybody having any doubt? Okay, let us continue. Now let us try the same thing with the spacey parts of speech tagger. Earlier in the morning I was getting some error. Let us see if I can be able to correct it now. Spacey is yet another library that is similar to NLTK, and using this also you can do the pre-processing, tokenization and everything. I think I'm able to load it. Let us try in here as well. Parts of speech tagging is clear to all. Anybody having any doubt, please ask. We are still on the same topic. Today we will be looking onto different aspects of it. Okay. What is EN core? Like I am downloading all the things that are related to the English language in here. EN stands for the English language. Okay. Now let us try out this code snippet. Import spacey dot load. This thing we have already done. And here I will be using NLP only. Spacey dot explain. Okay. अच्छा अभी spacey तो import करना ही है. Let us see. Am I getting any errors? Okay, I'm not getting. And it is saying in clear. See here, you need not go and refer to some tree bank explicitly, right? When we were doing for NLTK, it was returning you in the form of what? See here. What does it return? You can print the type of it. What is it returning? Okay, let us print the type and check.
Sorry. मैं बैठ के
Type of this thing. Let us print and check. Invalid syntax. Okay. Incomplete input. What are we missing here? Okay, I guess that was this variable was defined in the scope of this, right? So that's why it says this word underscore tokens is not there because its scope ends outside of the indentation block. So what we can also do here is print type of type takes no keyword arguments. Complete. Okay.
May one more parenthesis.
Yes.
One bracket is missing.
See, so it says it's a list. Why? In the list, we are also having the tuple. What is this tuple? Like the word and its corresponding parts of the speech. But if you see in the case, but in here we needed to refer to what VBD is, what VBG is. In the case of Spacie, that is a little bit more user friendly. You need not refer to what is PRP. Here it is saying it is pronoun personal, right? Was is a verb in the past tense. Being is a verb or the gerund or the present participle. Okay? Is it clear?
Yes, ma'am.
And here we are not doing the tokenization as we did in the case of Spacie. What we are doing here is token.text. It is calling the like, see here it is saying it is the attribute text of Spacie tokens. It is tokenizing the text data, है ना? It is taking up to 10. Let us see. 1 2 3 4 5 6 7. What is this 10? What is this 50? That we can vary and check. Okay, and this token dot tag, it is also printing, and Spacie dot explain, because of Spacie dot explain token dot underscore tag. So this is token dot text. That is what you are getting here. He was, what was there in your text. Then what tag the token was being assigned. Okay, he was being assigned the tag is PRP, that is the pronoun personal. Then was is the verb in the past tense. So we are also explaining that token tag, है ना? So that we are not confused what this particular category refers to. And tokens part of the speech, whether it's a pronoun, auxiliary. Okay, clear? And this is a little bit more friendly. But if you check out the tokens that the tags that are being assigned to every token in the sentence remains the same. Let us check for the first five: PRP, VBD, VBG, VBN, IN. Let us go above and check. PRP, VBD, VBG, VBN, IN. Correct? Is it clear? So what are the two different libraries that you can possibly use for parts of speech tagging?
Spacie and POC.
And
POC tag.
POC tag नहीं, NLTK library I am
Yeah,
asking.
the space.
Okay, please listen carefully, please. So is it clear till here, or do we need any more explanation? I am looking forward to your doubts. Please have a look and ask. Giving you 2 minutes. Please have a look and ask. So guys, any doubts?
Small dot, madam.
Yes, please ask.
Can we have for Telugu language also? Like, yeah, you said that EN is for English, no?
Yes, there is for Telugu language also, but then you need to refer to a different library. Do you want me to explain that? But that will be a little bit hard for you. Please tell, should I explain for Telugu also? Please raise your hands, those who want the demonstration for different languages. I myself don't know Telugu, so I'll prefer to do in Hindi. Hindi works for everyone. 1 2 3. Okay, fine. Let us do for some non-English language. Is it fine if I do for Hindi?
Marathi?
Because I
Marathi?
do for Hindi. Telugu you can try on your own. You just need to change the language parameter. Okay?
Madam,
Okay. Okay.
can we Can we do this for a Marathi language?
Arey, yes, I am explaining. Just hold on. I will explain for Hindi. You just need to change the language parameter and you can do it for different languages. So can all of you open this library? Maybe you can do hands on yourself, because if I do for one language, other will be like you have not done for my language. ठीक है? Okay, maybe just a second. Cancel. This library provides support for I think 10 to 11 Indic languages or maybe more. Let us check. The link is here for your reference, and it has been released very recently. So you may face a lot of doubts, but please refer to this link. Okay, it says the link not found. I'm not sure if I have the collab notebook. I don't have, I guess. You can use INLTK package for that. Okay. So will you do, or should I like run an example and show? What do you guys say? Do you want me to run an example, or you will be able to do on your own?
Please run one example, ma'am, anyway, in any one language.
Okay, okay. Then I'll need to refer to some online resource. Just give me a minute, okay? Just a second. Admit. Let me locate my notebook and I will share my screen in a minute. Okay, I think I can tell. Just a second. So there are three different libraries that you can use for Indic languages. First one is INLTK, that is Indic Natural Language Toolkit. Second one is Indic NLP, and third one is Stanford NLP. So Stanford parts of the speech tagger can work for it, and this works for 12 Indic languages. So I will tell you how. I will explain with Indic NLP. Does that work for everyone? I think the code was public earlier, but now it is not. Can I share it like after we are done with the lecture? I'll add the snippets towards the bottom, okay? Because I need to make some changes in the code file also. Is it fine? Okay. As you can see in my drive, I had lost access to it, so I will locate it and share it. But the thing is, you need to first do the tokenization pre-processing, and then you can go for the parts of the speech tagging in that. Okay. So coming back to what we were doing, we had explored it using Spacy and NLTK. So do you want me to do some another library, or shall we go for hidden Markov models now? Shall we go for hidden Markov models? So can anybody tell what hidden Markov model is? What is a Markov chain specifically? Let us begin with that. What is a Markov chain? Guys, what is a Markov chain? Have you gone through the lectures? I'm waiting for a response from your side. Have you gone through what are Markov models? Last lecture? Aditya Singh? Vandana? Pinky? No response today? Fuzlan?
So,
Yes, what is hidden Markov model? Like a
sorry,
basic
ma'am.
definition.
Actually, this time I'm not going through the lectures.
Okay. Anybody else in the class?
It's basically for predicting, no?
Yes, predicting what? Next sentence, previous sentence, or what?
Which follows, like with the next
Yes,
sentence.
yes, with whatever will follow. And we generalize that, like we take the bigram assumption and we assume that the word that is about to occur next will depend on the immediate previous word if we are taking the bigram assumption. But let's say we are taking the trigram assumption, then it will depend on the previous two words. So say I am typing something in here. So this is not cannot be an exact definition, but I will try to explain. So say I'm writing some email. So if you have seen, I think, yeah, okay, it is loading. I hope you see, like it is giving you the next words, right? Here it is giving you next 2 to 3 words. It is completing my current word automatically. But see, I didn't give it more than this. Then it is not able to give. But if I am doing like this, then if I hit tab, it will be automatically typed. So what is it? It is trying to give you the next words, right? Depending on your previous words. So this can be a little bit explanation of what a Markov chain is or what a Markov model is. So how do we do the coding in this is we will use the again the NLTK library and we are downloading the tree bank. And say I will just copy paste this snippet and then I will explain you what is it and how is it working. Just first be patient for a little while. We will go through it in detail. So now we are doing hidden Markov models. Okay. So now it will tell me like what all things are missing. So I will download them accordingly. First it says that I should download tree bank. What is tree bank? This pen tree bank. Okay. It is telling me to download this. So we will download it. Now again run it. Now again it says some dependencies are missing. So what does it say? The universal tag set it requires, which is missing. Okay. And if you want to know like what is a universal tag set is, you can go and refer to this link. I'm sharing the link in the chat box. Control A, Control C. So if you see here, it is just some sort of dependency it requires for you to perform this operation using the hidden Markov model. So now let us try to run it again. Why here it required now tag set is equals to universal. This is some corpus or some data that we are using. Okay? So tree bank में there are lot of sentences and we need to tag them, and those tag sentences we will pass through the hidden Markov model and check. Okay. So यहाँ पे print करा के भी देख सकते हैं. So first let us try to run it and then I will explain one by one. So it is still expecting more dependencies. NLTK.download universal. Okay, now we are getting some sort of output in terms of accuracy, micro average, macro average, and weighted average. Now let us try to understand each thing line by line. Okay, at any point you are having any doubt, please stop and ask. So Archana, you just joined the call, right? Archana SH. Can you please unmute? Archana HS. Are you there in the call? Archana? No response. Okay. So as I was saying, we need to understand each statement line by line. We know what import NLTK is. Everyone agrees. We know what import NLTK is.
Yes, ma'am.
And then we are calling some function from sklearn. Sklearn is some class or some package, say. And there, in that particular library, sklearn is scikit-learn, there are a lot of predefined functions and packages that are already existing for a easy availability and incorporating them into our code. So what we are doing from this library sklearn, we are calling this class model underscore selection, and then we are importing train test split. So what is train test split? Say there is any model, ML model, NLP model, we train it on some data. Okay, we train it on some data, the model has learned the weights, it knows now, oh, what thing should map to what, right? And then I'll give it some test data. Okay, I'll give it some test data and then it will generate the predictions. So say let me explain you with a very simple example what train split is and what test split is. Say we all are students, right? I am explaining some concepts, Pawan sir is explaining, other TAs are explaining. Assume your brain is the NLP model. Okay, so assuming your brain is the NLP model, we are trying to train it by teaching. Aditi, can you mute? Or I may need to remove you from the call. Aditya Singh. We will not resume until you mute the call.
Ma'am, you can press on or mute all buttons, so that all.
Okay, thank you. Thank you so much. Okay, so I was saying, assuming your brain is an NLP model, me, myself, Pavan sir, other TS, we are trying to explain you the concepts, right? I'm explaining what part of speech is, what word refers to which category, how we interpret it. So we are trying to train it, giving it some training data. We are giving you some questions in the assignments. You are trying to solve them. Your mind is getting trained. Then in the exam a new set of questions will come that you have not seen earlier, but now your brain has already been trained on those concepts, right? So your ML model, that is your NLP model, that is your brain, it will see some new data and then it will try to get the answers from them. Okay, so that is the testing data, and whatever answers you give are the predictions on the test data, and then we will evaluate how close your the answer given by you, that is your predictions or your generated outputs, are close to the actual outputs. Based on that we give you the marks and we calculate how many marks you got, what is your percentage. Similarly, in the case of NLP models, to evaluate their performance, there are metrics like accuracy, micro average, macro average, F1 score in terms of the classification problem, and say the output is a discrete value like 0 or 1, so it is a class. So there you will use the evaluation metric like accuracy, F1 score. But say your problem is predicting the price of the houses, so it is a continuous value. The price of the house cannot be 0 or 1, it will be in terms of lakhs or crores of rupees, right? So those are continuous values. So that is a regression problem. There you will have different models to evaluate their performance. Understood this concept of training and testing data? And we generally prefer, okay, I can see few hands up coming, only two. Others, what about others, remaining 10 to 12 people? All of you understood? I'm trying to explain it very in a very easy manner. And say some in some cases you will also see validation. What is validation split? These terms you may not have seen in the lectures, but these will definitely come when you are coding. Okay, train, validation and test. So train, so what are these data splits? So train and test I explained. What is validation? So say before the final exam, we give you some mock exams. You are in any coaching or you are in a class. Teachers will give you model test papers to solve some practice question that are similar in concept to what have been taught in the class, but they are twisted in some form. Some are new. Then what will happen is you will try to see those questions are also new, but then you will say, ma'am, what is the difference between the validation and test? So the difference is, assume your model test paper or the mock exam is the validation split. You see what answers you give, but then there you have a chance of correcting, right? You will learn from your mistakes. Okay, given this question I might have applied this trick, or I made this silly mistake, I can overcome it. Similarly, in the case of ML model or NLP model, there are several hyperparameters. What are hyperparameters? They are used to tune the performance of the model. Like it could be the epochs, the batch size, the learning rate. Okay, so there we will training is done. We will check the performance of the model on the validation data. That is also new data, but then there you have a chance of updating the model parameters to fine tune its performance, to refine its performance. But in the case of test data, now everything is fixed. From the validation you learn what should be the best learning rate, what should be the epochs, what should be the batch size. These terms will come later, or I will explain as and when they come. Okay, so on the validation, after the validation we have identified this is the best suitable value. What I will do, I will now everything I will fix and check the performance on the test data. So Vandana wants to ask some question. How do I unmute you? Um, Maybe you can try unmuting yourself.
Yeah, ma'am. Ma'am, actually, I want to ask this. Validation data is the part of training data?
Yes, yes. It, or
Okay,
it
thank
can be
you.
like, like the optimal split is not defined anywhere. Again, it is a hyper parameter. Generally what we prefer is we take 80 is to 20 split of training is to testing data, and out of 80% training data, 80% of training data, you take 10% or 15% as validation data. So in general, you can assume your train is to validation is to test split can be of the order 80 is to, no, 70 is to 10 is to 20 in general. But this is not defined anywhere. I'm just explaining it for a reference. Okay? क्लियर है? 80 हमारा ट्रेनिंग डेटा था, तो 70%, 10% ऑफ 70 विल बी 7. मतलब देख लेना इसको, ये कभी कभी वो 10% या 15% लेते हैं, तो आप रेशियो देख सकते हो, या तो आप ऐसे ले लो out of 80% of training data, नहीं तो you can explicitly also define this split. ठीक है? Clear है वंदना?
O- Okay, ma'am.
Anybody
Thank you.
having any doubt? Fazlan, okay. Anybody?
No, I'm sorry. I can't understand even a word in Hindi, ma'am. Could you please
What you
tell
didn't
in English
understand?
one?
The entire concept.
No, ma'am. The last thing that you told now, that training and testing and data validation data, that's the one.
Your voice is not at all clear to me. Can you?
I can't understand Hindi at all, ma'am. Totally. So,
But I can't even understand what is your question. Can you try speaking again with a better mic? Or maybe you can type in the chat box.
am I audible, ma'am?
Yes.
I can't understand when you speak in Hindi, ma'am. I don't even know a word in Hindi. Could you please make it sure that it
I
is in
am
English, ma'am?
I am repeating everything in Hindi as well as English as far as I remember.
The last thing that you told, that validation part alone, please could you?
So what I'm saying is out of 80% of the training data, you could either take 10 or 15% of the data as validation data, or you can explicitly define the split as 70 is to 10 is to 20 for train is to validation is to test. But these are just numbers you can fine tune depending on your model and your data and your problem at hand. Okay? Is it clear now?
Thank you, ma'am.
Okay, now let us see what this tree bank thing is, what we are trying to do here. So let us see. So now let us print. सबसे पहले so there was some words in this nltk.corpus.treebank and we have tagged them. Okay, so can we try, let us try like this, print corpus is a big document or a big chunk of data. Okay, bracket corpus parser tag set is universal print nltk.corpus. Okay, we need not take the tag set in this case. Okay.
Can we directly try printing tagged underscore sentences in this case? Or
I did that already if you saw, but we are getting the tag of every word, right? So if you can infer from here, then it is good. I need not see how I should print it. It's easy for me only. Okay, then I assume all of you understood that these are certain set of the words in the tree corpus and these are the tags that they have been assigned. Clear? Clear or not? As you said, I should print the tag sentences, so have I done. Clear? Are you clear? Are we clear or not? At least reply.
Yes, ma'am.
Okay.
Yes, ma'am.
So we took some corpus and we tagged the sentences according to the tag set that was universal. As I told you earlier, that there are a variety of the part of speech tagger that we can take, and this is from the universal dependency, as I was telling, UD, है ना? And we have print the tagged sentences. Now we can check what is the type of these tagged sentences. It should be in the form of a list. We can see that these are sort of brackets. So I can check the type of tag sentences. It is in the form of nltk.corpus. Okay, it is some another form. But what we are doing here, this model is trying to predict their given some training data, it has learned what kind of word maps to what word. So if you see this, you can assume the hidden Markov model is the word the word the the word the, it appears as a determiner most of the times, right? So given some testing data, what is the probability that this word the should be assigned the tag as determiner, or it should be assigned the tag as noun or anything else? As we saw earlier, the probability that the word or token reason should be assigned as a verb is say 80%. But in some cases it can also occur as a noun. Then in that case, what is the probability of it being assigned as the token nn? So the Markov model in a way will try to predict this. Okay, give me a minute. I'll have some water. So please go back today and again read what hidden Markov model is. Okay, I've tried to explain in a very easy way. And now let us see. We can get an idea from here as well what this model is trying to do. Now what we are doing, see, here I am varying the size of my training data and the testing data. As I told you, we take the test split as 80 to 20. So I define my test size as 0.2. Train underscore test underscore split is an inbuilt function in this library, and from there we call this package in which this class is defined. Okay, this function is defined, and what it takes as the input is the corpus, right, on whichever you want to do the prediction. And why we are shuffling the data, it can be the case that say we are doing some classification problem. All the sentences or all the samples that are having the target label as 1, they come in the training data, and all the samples that are having the label as 0, they are coming in the testing data. So my model can never be able to learn in this case when it should give the prediction as a 0, or say all the samples with the label 0 were appearing in the training data, and all the samples with the label 1, they were appearing in the test data. My model never learned in what cases the predicted class should be 1, what should be the nature of the data in that case. So to avoid such scenarios and enable the efficient learning of the model across the diverse variety of the input samples, we set this shuffle equals to true. Clear? Is it clear to all? Is this point clear to all
Yes,
till
ma'am.
here?
Yes, ma'am.
So now we can also print the length of the train data and the test data. ठीक है? चलो, let us print and see. And I am speaking in English only, so I assume nobody is having any problems. Once or twice it can be the case because my first language is Hindi only. But I will try to repeat in English also. So we can see the length of the train data set is this much, and what is the length of the test data set. Test data set. So if you can check, the total comes out to be what? 3131 plus 783. How much? 4, 8 and 3, 11. Then 7, 8, 9 and 3. Correct? So you can check 0.8 into 3914. 3131. Is it clear? My screen is visible to all.
Yes, ma'am.
Clear, Anna? What we are saying is being is validated also. So we are saying here that the test data is 20% of whole tag sentences, and we printed the tag sentences. How did they appear out? Here we printed, na? Right, here we printed like this. There are some multiple sentences which we have tokenized first at the sentence level and then at the token level, word level, right? ठीक है, this was our input data. What is corpus? A big document or a big chunk of data, say multiple Wikipedia articles or some, or the content of some website, है ना? So that corpus we took from the tree bank. We tagged those sentences. What was our tag set? We took it from the universal, where the target categories I think are of 45 nearly, but we saw in pen tree bank there were only 36 target categories. Okay, then after that we printed these tag sentences. Then these tag sentences I divided into training and testing data, and I took the train is to test split as 80 is to 20, right? And what is the objective of my hidden Markov model? To predict the parts of the speech for the testing data. Okay, because I said earlier also that hidden Markov model is also a type of the tagger. I had explained you very first example, if you remember, with the average perceptron tagger, right? But I told you that we can use a variety of other taggers. Where did we write that point? Let us go and check. See that we can use a variety. These were the tree banks and these were the different parts of the speech taggers. And here one of the taggers is from the hidden Markov model as well, as we are seeing here. Correct? Is it okay? Clear till here to everyone?
Yes, ma'am.
So see, as I have clicked on it, can you see some paragraph appears, which is giving me the detail about it, that it is a generative model for labeling the sequence data. And labels are here in terms of the parts of the speech, whether it's a noun or a pronoun or a verb or adjective. ठीक है? Clear है?
Yes, ma'am.
So can anybody tell me what is the difference between the discriminative model or the conditional model and the generative model? This is a very important question that there will be multiple questions from this particular topics that I am explaining.
Discriminative models generally classify within certain labels, and generative models, it's like ChatGPT, it generates a lot of text,
Yeah.
the basic
So,
sense.
yeah, let me, you are nearly correct. So what discriminative model does is given some corpus of the data. So let me explain you this way. So say D is my data and given some data, it will try to predict what classes that the data belongs to. So it moves from data to the class. But what is the case of the generative model? Say I tell you to write an essay on my favorite pet, like teachers used to give us in our primary school days, right? My favorite pet, my family. What they gave you is a class. Class refers to pet or family or a trip with my family or a day in the train, like that. And what you are doing, you are generating a big essay out of that, right? So what you are doing is you are generating the data, है ना? You are generating lots of samples around it. Okay, so you can refer to these are very important concepts. I can assure that nearly there will be 2 to 3 questions, and even if there are not, if it is an important concept, you should know what is the difference between the generative model and the what another model, discriminative model, how do they
Native
work,
model.
what is the theorem, which theorem do they employ mostly.
Generative model uses joint probability
Mm-hmm.
and discriminative. Ma'am, I think generative model use joint probability.
Yes, and
Yes, and
Descriptive model use conditional probability.
yes. So
yes.
in general, you could say these models revolve around the Bayes theorem, right?
Yes, ma'am. Ma'am, generative models.
Both of them. You can see, like, I think you have pointed out correctly. So, it's my humble request to everyone, and this is the last time I have allowed the entry at 8:13 p.m. More than 60% of the lecture duration has passed. Since there was a request today, I have allowed, and there was no previous announcement. From next week onwards, I am not going to allow anyone who joins after 7:20 p.m. at max, because I cannot keep on repeating the same concepts again and again. So that is you have to manage. I cannot allow in my class explaining the same concepts again and again, moving back every time and allowing people in the call.
Ma'am, please like go on. Like if someone comes late, they have the recording.
Aditya, let me give the instructions clearly. We are we have been instructed to teach in a certain manner. Kindly don't interrupt, otherwise I will remove you only from the call, if it is fine by you.
Okay, ma'am.
There is a lot of interruption in every lecture from your side. Are you the TA or am I the TA? First, let us clarify this thing.
Ma'am, please carry on the class.
Please understand and cooperate. If you don't cooperate, I have full freedom to remove you from the call. We have been
Okay, ma'am.
instructed to perform our duties in a certain manner. Kindly maintain the hierarchy. Do not try to overpower. If there is any interruption from your side, Aditya, I am definitely going to remove you from the call, subsequent calls.
Ma'am, please continue. We have another class also.
Okay, as I was saying, we can use the hidden Markov model taggers. And as I had explained, we will first try to train it on the training data. Okay, say we got the HMM model that was trained on the training data. Okay, and once this model has been trained, we will try to predict what tags it is giving for the words that appear in the test data. Is it clear? This point is clear. HMM model, we have created an instance and we are calling this hidden Markov model tagger from the NLTK library, and we are training it using what data? Training data. Okay, Do not call the train function on the test data, because test data is only 20%. So there it may not learn correctly how to map what word. These models, NLP models, deep learning and ML models, they require a lot of data for the model to perform the training. Okay, is it clear till this point to everyone? HMM model. Is it clear till this point? HMM model, how is it working? We have
Yes, ma'am.
we are calling the train function on the train data solely. Okay, and then what we will do, we will try to predict the labels for it for on the test data. Okay, so what we are calling is, this is the term of the list comprehension, as I told you in the previous lectures also. We are iterating for the word comma tag in sentences, since it was a tuple. Like if you remember, it was in this form, right? He, and what was the tag it was being assigned? PRP. So we are iterating for the word comma tag in sentences. Sentences was your whole corpus, and we are going to assign the tags to it. Okay, and out of this, like for the testing data, first it will try to predict what is the tag that we should get here, है ना? What is the tag we should get here? Then it will pick the second instance tag, है ना? And then we will keep it in this list, correct labels. Okay, from the actual data. Okay, say we had the actual data, and there I had he, and the category of this tag is PRP. This is the word, this is the tag. We are iterating over it, and we are storing all these tags in the in a proper order, in the form of a list. Okay, list is an ordered data type. The order matters here. And then I am trying to predict the labels of the test data using the hidden Markov model that I had trained on some training data. Okay, so for all the sentences, and I will store the predicted labels also in the form of a list. So what I'm going to do, I'm going to iterate over the sentences in the test data, and then I will keep on adding them to the list. What? The labels that hidden Markov model is predicting. So HMM model is my hidden Markov model that I have built, and I'm calling the tag function on it for word for word, comma underscore in sentences. So this is something that it is going to predict, right? This will be the predicted tag, and this tag for this, like it will be in the form of a list, and then we are going to store it here. Okay, and then these are the predicted labels. So, and now this is, here comes your evaluation of the model. Did you understand that here we took the corpus as the input to the model, then we did the train and the test split, then we trained the model on the training data, we got the what is the actual category the particular word should belong to, and we also got the predicted labels. Okay, now that we have the correct labels and the predicted labels, as I said, we try to evaluate the performance of the students or the performance of the data for a particular task. So this is my evaluation matrix in terms of the classification report. What I am going to do is sklearn, again some library from which we are importing the evaluation matrix. From there we are trying to import the classification report. In that, these evaluation metrics are already defined. So what are the evaluation metrics already defined? If you see the output, accuracy, macro average and weighted average. Okay, accuracy is how many. So I will give you some link to understand what is accuracy, what is macro average. So you can assume it like, we had total of n samples in my data, in n samples in test data. So out of this, in this case, accuracy will be what? Number of samples, number of test samples for which corrected label, for which predicted label is equal to corrected label, like the actual label that should have been there, divided by the number of correct labels, or you could say the number of total number of test samples. Clear है? Is it clear? Is it clear to all? So there were 4 main steps as we can analyze. First is getting the corpus. For input, then we are taking the tagged corpus, right, as the data. Then we are doing the train test split. Then after that, what we are doing is training the model. Fourth step is getting the actual or corrected labels. And fifth step is evaluating the model performance. Clear to all? Is it clear till this point to all? Any doubts still here to anyone? Any doubts still here to anyone? Okay. So let us proceed. Now we are going to analyze what is the dependency parser. Why we want to analyze? We are doing the parts of the speech tagging so that we can, and here I just missed one point. Here see, you are getting an accuracy of how much? We didn't discuss on that. We are getting the accuracy of 92%. That means out of the total samples, my model is 92 for the number of the test samples that are there, and 92% my model is predicting the correct labels for the testing data, and this is quite a good accuracy, right? So also this accuracy and test also it will depend on what your nature of the data is, what is your train is to test split. So you can experiment with this value and see if you can reach more accuracy. Okay. So now let us analyze the how the different words depend on each other. As we said that given any sentence, it is a sequence of words. So let us see how to visualize the dependency of one word on another in terms of the parts of the speech tags. As I said that maybe you can also refer to this link, which helps you analyze how we are deriving the parts of the speech. Okay. So see, if you can see my screen here, can you see my screen? As I said, the part. Can you see my screen, all of you? Or should I
Yes,
zoom
ma'am.
Yes,
in?
ma'am.
Okay. So as I said, the part of the speech for a particular word, it depends on what is the context of the surrounding words, right? So here, whether the verb use will be used as a verb or the noun, है ना? That will depend on its previous words as well as its subsequent words also, right? Like this uses will determine the parts of the speech for the future words also, right? So in uses ka what is the part of the speech, it depends on the previous one, and how it is affecting the part of the speech for the subsequent words, that all is shown. So this visualization we can also do. How? If you remember, for this sentence only we did the parts of the speech tagging, right? So let us try to see if we can also analyze. So let us see, but it does take quite a lot of time. So if you see, we remember earlier also that he was being the assigned the part of the speech as pronoun, right? And it is also showing you different dependency styles. Okay, these are all of those. And subject, past, auxiliary. Need not refer for more detail. This is just to help you visualize how it is affecting the previous and the subsequent words part of speech. I hope it is clear to all. Is it clear? And when we are running this particular cell, since it is being rendered to a particular server, it will keep on running. So maybe you can go to runtime and interrupt execution, so it will stop. Okay, you can do this kind of analysis also. Dependency parse trees will come in the subsequent lectures. There also we will cover it, but today is just for reference so that you have some clarity. Is it clear? So anybody, any doubts? Okay. Any doubts to anyone? Anyone till here? Okay. So let us continue. So we have covered till this part. Now if I want to save this dependency image, if I want to save this dependency image, I can call this this snippet of code. So what it will do, spacey.display, whatever is being rendered on the screen, that is style is in terms of dependency, and we are not saving the Jupyter notebook. We just want to save this particular file, है ना? So the outputted document or the outputted image will be saved by this name, dependency underscore plot.svg, and what is the path where you want to save it and in which format I want to write it is svg. You could also write it in the png format. So let us see if I can save this image, and let us visualize the saved image. If I'm getting the same image as the output, so here are we able to see this? And if I have downloaded, let us see if I have the dependency for this. Is it clear? We are able to save this image also, and it appears here on the left hand side of my collab notebook with the name as dependency underscore plot. svg is yet another form of saving the image, just like png, jpg, but this is of higher quality. ठीक है? Is it clear? Or anybody having any doubts still here, you can ask. So since there is no response, I am assuming there are no doubts. Sorry. Uh, this parts of the speech, as we saw, we used it for one task earlier, that is the dependency parsing. These are the different applications why we do the parts of the speech tagging. Okay, one application we have seen is the dependency parse tree, and I also showed you the saved image in terms of this. See, these are the different parts of the speech: pronoun, auxiliary, verb, है ना? ठीक है? So, and these are the dependency parses which you will see in the future lectures, and we will discuss then in detail, more further detail. And yet another thing what you can do is pattern matcher. Like, let's say when we are filling some online Google forms or application for some admission, what happens is it says that the password should have one uppercase, one lowercase, one digit, some special character, total password length, total number of characters should be more than 8, or total number of characters should be 8 or more, right? So these are the different patterns. For email, if you see, what it says is that it can be anything of the form xyz at. Some domain name should be there. .ac.in, है ना? xyz at gmail.com. Gmail, that is some organization name, है ना? Organization name or something, and then followed by in dot there should be some domain name, like for academic institutions you have ac.in .ac.in, है ना? And for commercial institutions you will have .com, है ना? For educational coaching institutes you will have edu.in, right? So these are the different things that appear in your pattern for a valid email to exist. At the rate should be there, dot should be there, है ना? No other special characters other than underscore or something should appear. Like there are several constraints. I'm not saying this is one of the valid constraints. So there are several constraints. There are several patterns that we should check before taking it as a valid email or not. है ना? Sometimes when it is not valid, it will say that the password is not correct. It will be highlighted in red, and it will tell you that you are missing something. What you are missing, it won't tell, but it will say that this is not correct. So what they are doing is they have a fixed pattern in their mind, right? The algorithm has been trained such that it should have a specific pattern, only then it will render the further fields. If it does not match, then it will not render. Is it clear till this point? So how is it related to parts of speech? I am going to explain. First of all, this is clear. What are different patterns in terms of email, in terms of passwords that they require you, input combination? Specifically focus on the email part. For email, that you should have a specific format, at the rate, dot, domain name and stuff. Okay. So what we are going to do here is, this is called as the pattern matcher. We are going to match a particular pattern. Again, I am using the Spacy library for this, and from the matcher class, I am importing this function matcher that has been trained for doing this specific task. Okay, and then you see this one thing, like you are using this Pentree, Bank, or Hidden Markov model tagger, or Stanford parts of speech tagger, or average perceptron tagger. They have been already trained on vast corpus of data that is available on the web, in a lot of books, on lots of social media websites and everything. And then now you're giving it some sentences of your own. It is giving you the correct predictions, and we are evaluating what is the accuracy and all. So this is all the game of train and test, and refining the model and coming up with better solutions. Okay, so what I'm going to do here is, I'm going to try to match a particular pattern. Okay, so we are taking, first of all, I have loaded it for the English language, Spacy model for English language. You can also see how to load it for different languages by changing in the argument here. Okay, so now let us say we want to match the patterns here. Okay, so I am taking in terms of lambda of x, where x of 0, it means that it should take the first item of the list. If you remember, when we are having the tagged words, how do they appear? So word appears, then its tag appears, है ना? So what I'm going to do, say x iterates over this. So what it will do, it will take the first item. X of 0 means it will take the first item, or say it was in terms of a list this way. Okay, and there was Charles, that is NNS. ठीक है, तो अब ये क्या कर रहा है, these are two different items in the list, it will take only the first item. ठीक है, जैसे इन्होंने they have given one example here also. August is there, NNP is there, with and its part of speech is there. So what I'm going to do, I'm going to pick lambda here. For with this, let us try to print what is the first word here. Let me print it in a separate doc. So let's print word here, first word. This is a function lambda. So now I want to join it. So what does it say? The first word that you have taken, let us come here and see. So the first word we have taken, this is just a function that we have defined. So the function will take some argument, as I told. So we are taking this argument, first word of comma x. So let us try to print what is map. Let us see what map is. So map is yet another function in Python. What does it do? So first let us see this example, first word example. We are having the tuple of this sort in here, and what it should do, it should take it like this. August with US. It is taking every word in this tuple. So what I am going to do, lambda of x, like taking the first word, we are going to convert it in the form of the list. Okay, we are taking it in the form of the list, and then we will join them in the form of the strings with the help of the space. So what will happen, this first word will return you it in the form of the list. Now this list, you want to convert it in the form of a string. So what you are doing here, you are using this dot join and then this thing. It is taking and then it is trying to print. So we are calling on some corpus of the earlier trained data set that we defined. There we are calling for all the sentences and then we will print the corpus. So let us see how does it appear. Let us try to print the corpus. Is it clear? Is it clear to all? Here if you click on it, then more sentences will appear. Clear hai? Like here the input was were the tag sentences, and now I am trying to create the corpus out of it, because from this corpus I will perform the pattern matching. Whatever the condition is defined in terms of email, if you want to check, you can put that pattern or the regular expression, and then it will match and return whether it matches or not. You didn't understand what happened? Fuzlan is writing no. So is it for not understanding this concept? Should I go over it again?
Yes, ma'am.
Didn't understand.
Yes, ma'am. I didn't understand.
Okay. So see here. What I am saying is, let us take the small example. I am taking this small example. Like my input sentence is like this. Okay? This is my input sentence. What first word will do, the function that I have defined here. So can you help me to do it, Vandana? So first word it will take from every tuple. What it will take? Can you tell? Like it will go over this entire sentence. So can you help me like what it will take, what I should write in the terms of list?
Aug-
Huh?
August.
Then?
August with tagging or the
Yes.
word.
See, x of 0, what does it mean? It should take the tag or the word. You only tell me.
August with US.
US. ठीक है यहाँ तक clear हुआ? Is it clear
Yes,
till this
ma'am.
point to you? So we got this after this step. First word. ठीक है? Assume. You got till here. ठीक है? Now what joiner is doing? It will iterate over this list. It will iterate over this list. And what it is going to do? It is going to pick every word. है ना? It will convert it into string. We are doing the join operation. Join is used to it is used to join the two strings together, and with the help of what character? Space. This is the space character. It will join. It will read through this list. Already they are in the form of the string, so we need not convert. So what it will do? It will do like August, and since I have given the joining joining with the help of the space. What it will do? August with US. ठीक है? But say I had given the join character like this. I had given कि when you are joining, you join with the help of some dollar symbol. So let us see in that case. Okay. I think we were calling it in a separate notebook. Just a second. Let's see here. So say here we are doing the joining with the term of some dollar symbol. Now I want to print my corpus. Is it clear now? Earlier what we were getting, but as Duke University, and the separator was the space token, right? You see here.
Ma'am, this corpus is came from.
We already took na train and the test data from the tree bank. We were doing the earlier example, hidden Markov model. It came from there only. I took it as a reference from there only. So what we are seeing here, it is joining with the help of the space, right? But as Duke University. But when I gave the joining character as dollar, how is it joining? The dollar appears as the joining symbol. Clear? Is it clear now,
Okay.
Vandana?
Yeah, ma'am.
So it's nothing like, say you have got this from the output and you again want to map it into the original sentence. Just the back conversion. As of now, you assume it like that. Pattern matching we will come later, but this is just some technique to help you understand. No logical explanation or anything. Okay? Just some simple Python programming. Clear? Is it clear to all? Anybody having any doubts till this point?
Ma'am, I also have a doubt in the starting of this presentation, in this meeting.
Yes.
Actually, ma'am, I was trying. So it took
Sorry, I
it
missed your
as
question.
a
I missed your
simple, I think, noun.
Vandana, I missed your question. Can you please repeat?
Actually, ma'am, I have written a sentence for taking the tagging of that sentence in the starting of this meeting.
Mhm.
So I wrote there Vandana in lowercase. So the code given to me, the answer Vandana is not as a proper noun or something else.
Can you
It
share
give
your
me
screen? I will tell.
yeah, sure, ma'am.
Are you sharing, Vandana? I cannot see. Yes. So show NLTK Perceptron. My name is Vandana. It is giving now. My name is noun. It is giving Vandana is a proper noun. What is the issue? Run it again. So see, why is it doing like this? there is a specific order, like a specific rule set, like the name of any organization or the name of a person, you should capitalize it, some name of some important building or a monument or an important person. So if you are keeping it in capital, it is analyzing correctly. But because this is Vandana, it is a Hindi word specifically, and I think it is trained on English data, so that's why it is not able to analyze. Maybe the corpus on which it is trained, there the probability of Vandana appearing as an adjective, that is the token JJ, is higher. That's why it is assigning it as the token JJ. Okay? And that's why we say, na, every model is not 100% accurate, right?
Okay, ma'am.
Also, it is language specific. Maybe it is not recognizing your name in the lower case. Technically and logically, when we write in English language, you should always keep the name starting with an uppercase letter, right? When you are doing in the uppercase, it is doing correctly, right?
Yeah,
So
ma'am.
that's why we say it's a rule based approach, है ना? The given a particular word, if it is preceded by something, then what it will change into, there are certain set of rules. Okay, one such
Okay,
rule
ma'am.
has been discussed in the lecture. Please go through it. So anybody else having any similar sort of doubt, you can go ahead and share your screen. I'll be happy to solve. Upload the codes discussed by you. Definitely, I am uploading for each and every lecture, and I'll upload for this one as well after the class gets over. Maybe by today or tomorrow. Anybody having any other doubts, you can please go ahead, share your screen. Where we get the links, ma'am? I already shared the Drive folder and the YouTube channel link. So can anybody post the Drive link and the YouTube channel link for Fuzlan to access right now in the meet? Vandana, can you please do that? Right now, can you put the links so that Fuzlan may also access the course material?
Have to check, ma'am.
Yes, Saurav has put. Could you, Saurav, also please share the YouTube channel link? So Fuzlan, please save these links. Everything related to the course I will put here only. The recorded video will be uploaded on the YouTube channel link, and the code notebook and the related everything will be uploaded in the Drive. Also for the previous recordings you can refer. So let me see if anything else was remaining. Yeah, so we were trying to come to the matcher part. In between, Vandana asked a little doubt. So let me complete that matcher part, how we are going to use it. So what we are going to do is, after I have joined the corpus, I'm going to match it with the actual vocabulary. Okay. So let us match it and check. NLP was something that we had downloaded earlier. If you remember, NLP was something EN Core Web. You can check the code snippets previously. So let me remove this. I hope all of you understood this. I'm commenting it. You can uncomment later for your reference. Let me run this again. So okay. Now we are. It says that this matcher is not defined. First, let us import this matcher from spacey.matcher. We want to import this. So let us import. Doc may we have passed the corpus that we obtained, and we are going to match it with the original vocabulary. Let us see what does it output. can print math list is equals to matcher of doc. Can pre-process the output match list. Okay, it says something is not there in the column. So I need to check why I'm getting this error. Just a minute. Let me resolve it. Okay, we didn't add anything actually to the matcher. This code snippet I am missing. Matcher mein there should be some specific pattern should be defined, right? As I told you that in case when we are matching whether the email is valid or not, so we should define something, right? So here we are defining certain operators and stuff. Let us check whether they match or not. So here we want our pattern to be something like this. As I said, this part of the speech can be used for matching some specific pattern. So what that pattern is, say I want to use some proper noun, then it should be followed by met, and then there should be any word, one or more occurrence. This character question mark stands for one or more occurrence of any word, zero or more. Like there can be one word or zero word, one or zero or one occurrence. Occurrence. So here we needed to define some tags that first of all we have added. See, met should be there in my matching pattern, and what I am adding, dictionary. The tag should be a proper noun and it should followed by a plus symbol like one or more characters, and then if it is a digit alphabet, then it should be followed by zero or more characters. Lemma should be meet. For the word met, the base form should be meet, right? And this way, so the whole pattern comes out to be like this: proper noun met any word. So you can decode this matcher pattern to be in this form. Okay, met, okay. And then we are having some proper noun. NNP is proper noun plus it should be some alphabets followed by one or more occurrences. Lemma of word this met should be meet, and this for this when we are adding this tag, it should be alphabet, and then another in the end it should be again an alphabet followed by one or more occurrences. So what I am doing here is I will go to my corpus and see where it matches like this. Okay, so what we are going to do is in my doc. So what is my doc? Print. So let us see where this these kind of patterns are there. So what does it give me as an output? Is Pacific nations will meet in Australia. So Pacific nations. Let us search in this doc. Pacific explanations. See, here we are getting that pattern, proper noun, then some base form of the word meat should be there, and then again a proper noun, and then there can be one or more occurrences of it, right? Like one or more words can be there. Understood or not? Anybody having any doubt here? It is giving you like this. And we can also check for this sentence. Mr. Nixon, matlab this is a proper noun, and then we have the base word met and Mr. Bush. So if you have studied TOC or theory of computation, you would know the meanings of this. Plus means one or more words can be followed. Here zero or more words, zero or more words. Understood? How we are using the parts of the speech to perform the pattern matching. It is just an application, no logical explanation or anything. Just some Python code to do it. Clear? Anyways, I'll be sharing my collab notebook link so you can refer to it also for the future reference. Is it clear to all? Anybody any doubts? Please stay back and ask. Others can leave the call. Anybody having any doubts, they can wait and ask. Others can leave the call. Anyways, I'll be uploading this recording and the lecture notes, collab notebook in the form of the PDF. So you can run it on your own end and check. Okay? Okay, thank you. I hope all of you understood. Please try to join timely by next meetings. Okay, thank you all for joining. Thank you so much. See you in the next class.